Hello students, welcome to this lecture 1 Polynomials. So in today's lecture, we'll discuss relationship between zeros and coefficients of a polynomial. Then we'll summarize whatever we covered in our previous lecture and in this. Okay, so let's get started. You have already seen that zero of the linear polynomial. You know the linear polynomial that can be written as ax plus b, where a and b are real numbers. Okay, so 0 of a linear polynomial ax plus b is minus b upon a. Okay, so here you can relate zeros of a linear polynomial with its coefficients. Okay, so here minus b upon a. So here b is basically the constant term of a linear polynomial x plus b. Okay, and the a is basically the coefficient of x of a linear polynomial x plus b. Okay, so 0 of a linear polynomial x plus b is basically minus of constant term divided by coefficient of x. Okay, so now let us take a quadratic polynomial. Okay, say p of x is equal to 2x squared minus 8x plus 6. Okay, so in class 9th, you have learned how to factorize quadratic polynomial by splitting the middle term. Okay, so here we need to split the middle term minus 8x as a sum of two terms. Okay, so whose product actually is 6 times 2x squared, that is equal to 12x squared. Okay, so we can write this quadratic polynomial 2x squared minus 8x plus 6 as 2x squared minus 6x minus 2x plus 6. Okay, and this is equal to 2x times x minus 3 minus 2 times x minus 3. Okay, and here x minus 3 is common into terms. Okay, so x minus 3, this factor into x minus 2. Okay, so 2x minus 2, and this is equal to 2 times x minus 1 times x minus 3. Okay, so the value of p of x is equal to 2x squared minus 8x plus 6 is 0 when x minus 1 this is equal to 0 or x minus 3 is equal to 0. Okay, so here for here factorize first this quadratic polynomial into two linear factor. Okay, so we factorize it as 2 times x minus 1 times x minus 3. Now if we equate to 0, then either x minus 1 this is equal to 0 or x minus 3 is equal to 0. Okay, so if x minus 1 this is equal to 0, then the value of x is equal to 1, and when x minus 3 is equal to 0, then the value of x is equal to 3. Okay, all right, so x is equal to 1 or x is equal to 3. Okay, so the zeros of 2x squared minus 8x plus 6 are 1 and 3. All right, so the zeros of this are 1 and 3. So now you can observe that sum of its zeros, that is basically equal to 1 plus 3 is equal to 4. This is equal to minus of minus 8 by 2, and we have the quadratic polynomial, that is 2x squared minus 8x minus 8x minus 6 plus 6. Okay, so this is our given quadratic polynomial, and here the coefficient of x is basically minus 8 and the coefficient of x squared this is equal to 2. Okay, and the constant term is 6. So sum of its zeros, that is equal to 1 plus 3, that is equal to 4, and this is equal to minus of minus 8 by 2, and this is equal to basically minus coefficient of x divided by coefficient of x square, since the coefficient of x is basically minus 8 and the coefficient of x square is 2. Okay, so sum of its zeros can be written as minus coefficient of x divided by coefficient of x square. So if we have given two zeros of a quadratic polynomial, then their sum, this is equal to minus of coefficient of x divided by coefficient of x square. Now product of its zeros. So product of its zeros, this is basically 1 into 3, since 1 and 3 are the zeros of 2x square minus 8x plus 6. So the product of its zeros, this is equal to 1 times 3 and this is equal to 3. And you can write this as 6 over 2. And here the constant term is 6 and the coefficient of x square is 2. So product of its zeros, this is equal to constant term divided by coefficient of x square. So now let us take one more quadratic polynomial, say p of x, this is equal to 3x square plus 5x minus 2. So by the method of splitting the middle term, here we will factorize this quadratic polynomial into two linear factors. Okay, so we can factorize the middle term 5x as plus 6x minus x. So as 6x times minus x, that is equal to minus 6x square, and this is basically the product of 3x square times minus 2. Okay, so 3x square plus 5x minus 2, this is equal to 3x square plus 6x minus x minus 2, and this is equal to 3x times x plus 2 minus 1 times x plus 2, and this is equal to x plus 2 times 3x minus 1. Okay, so here we factorize this quadratic polynomial into two linear factors. One is 3x minus 1 and other is x plus 2. Hence the value of 3x square plus 5x minus 2 is 0 when either 3x minus 1 this is equal to 0 or x plus 2 is equal to 0. That is when x is equal to 1 by 3 or x is equal to minus 2. So the zeros of 3x square plus 5x minus 2 are 1 by 3 and minus 2. Okay, so now we can observe that if we take sum of its zeros, that is equal to 1 by 3 minus 2. Okay, and this is equal to minus of 5 by 3. And here we have given the polynomial 3x square plus 5x minus 2. So here sum of its zeros, that is equal to 1 by 3 plus of minus 2, and this is equal to minus of 5 by 3, and this is equal to actually minus of coefficient of x divided by coefficient of x square. So here we observe that sum of its zeros, this is equal to minus of coefficient of x divided by coefficient of x square. Now if we take the product of its zeros, that is equal to 1 by 3 times minus 2, and this is equal to minus 2 by 3. And here the constant term of the quadratic polynomial 3x square plus 5x minus 2 is minus 2, and the coefficient of x square is 3. So here product of its zeros, this is actually equal to minus 2 over 3, and this is equal to constant term of this quadratic polynomial divided by coefficient of x square. In general, if alpha and beta are the zeros of the quadratic polynomial p of x, this is equal to ax square plus bx plus c, where a not equal to 0, then you know that x minus alpha and x minus beta are the vectors of p of x. So now you can write p of x, this is equal to ax square plus bx plus c as x minus alpha times x minus beta. And here the zeros of this quadratic polynomial are alpha and beta. And now if we take, if we here basically here ax square plus bx plus c, this is equal to k times x minus alpha times x minus beta, where k is a constant, and this is equal to k times x square minus alpha plus beta times x plus alpha times beta, and this is equal to kx square minus k times alpha plus beta times x plus k times alpha times beta. And now if we comparing the coefficient of x square, x and constant term on the both sides, okay, so comparing the coefficients of x square, x and constant term, we get these. Okay, so a is equal to k, b is equal to minus k upon k times alpha plus beta, and c is equal to k times alpha beta, and this gives us alpha plus beta, this is equal to minus b upon a. Okay, and the product alpha times beta, this is equal to c upon a. So alpha beta are Greek letters here pronounced as alpha and beta respectively, and we will use a letter, one more letter, this pronounced as gamma. Okay, so this letter pronounced as alpha, this letter pronounced as beta, and this letter pronounced as gamma. That is sum of zeros alpha plus beta, this is equal to minus b upon a, and this is equal to minus coefficient of x divided by coefficient of x square, and product of its zeros, this is equal to alpha times beta, and this is equal to c upon a. Okay, and this is equal to constant term divided by coefficient of x square. So now let us explore more some examples. So example, find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficient. Okay, so we can find the zeros of the quadratic polynomial x square plus 7x plus 10 by using splitting the middle terms. So we can split the middle term 7x as 5x plus 2x, so that 5x times 2x, this is equal to 10x square. So we can write this quadratic polynomial as x square. We can write this for x square plus 7x plus 10, this is equal to x square plus 5 plus 5x plus 2x plus 10, and this is equal to x times x plus 5 and plus 2 times x plus 5, and this is equal to x plus 2 times x plus 5. Okay, so we have x square plus 7x plus 10, this is equal to x plus 2 times x plus 5. So the value of x square plus 7x plus 10 is 0 when x plus 2 is equal to 0 or x plus 5 is equal to 0. That is when x is equal to minus 2 or x is equal to minus 5. So therefore the zeros of x square plus 7x plus 10 are minus 2 and minus 5. So now we have to verify the relationship of between zeros and the coefficients of its polynomial of this polynomial. Okay, so now sum of zeros, this is equal to basically minus 2 plus of minus 5, and this is equal to minus 7. Okay, and we have this quadratic polynomial x square plus 7x plus 10. So here the coefficient of x square is 1 and the coefficient of x is 7 and the constant term is 10. So sum of zeros, this is equal to minus 7 and this is equal to minus 7 divided by 1, and this is equal to minus coefficient of x divided by coefficient of x square. So here coefficient of x is 7 and the coefficient of x square is 1. So sum of zeros, this is equal to minus coefficient of x divided by coefficient of x square. So verified. And next, product of its zeros. So product of its zeros, this is equal to minus 2 times minus 5, and this is equal to 10, and it can be written as 10 over 1. So the constant term is 10 and the coefficient of x square is 1. So 10 over 1, this is basically equal to constant term of this quadratic polynomial divided by coefficient of x square. So we get this relationships, product of its zeros, this is equal to constant term divided by coefficient of x square. So now let us move to next example. So in this example, we have to find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. So first we can factorize this quadratic polynomial into two linear factors. So we know this formula, a square minus b square, this is equal to a plus b times a minus b. If we use this identity for factorizing this quadratic polynomial, then we'll get x square minus 3, this is equal to x minus root 3 times x plus root 3. So the value of x square minus 3 is 0 when x minus root 3 is equal to 0 or x plus root 3 is equal to 0. That is when x is equal to 3 or x is equal to minus 3. So therefore the zeros of x square minus 3 are root 3 and minus root 3. Okay, so now we have to verify the relationship between zeros and coefficient of it. So now the sum of zeros, this is basically equal to root 3 plus minus root 3, and this is equal to 0. So here if we compare the coefficient with this sum of zeros, so we have the quadratic polynomial x square minus 3. Okay, and here for this quadratic polynomial, the coefficient of x is basically 0. So here the sum of zeros, this is equal to 0, and you can write this is equal to minus of coefficient of x divided by coefficient of x square. And then product of its zeros, this is equal to root 3 times minus root 3, and this is basically equal to minus 3. Okay, and you can write this is equal to minus 3 upon 1. So here for this quadratic polynomial, the constant term is minus 3 and the coefficient of x square is 1. Okay, so minus 3 can be written as minus 3 upon 1, and that is basically equal to constant term of this quadratic polynomial divided by the coefficient of x square. Okay, now let us move to another example. So in next example, here you have to find a quadratic polynomial, the sum and the product of whose zeros are minus 3 and 2 respectively. So in this example, basically we have given sum and the product of this quadratic polynomial are minus 3 and 2, and we need to find a quadratic polynomial. So here basically we'll use relationship between zeros and coefficients of a polynomial. Okay, so let us consider the quadratic polynomial b x square plus bx plus c, and its zeros be alpha and beta. So we have these relationships, sum of its zeros alpha plus beta, this is equal to coefficient minus of coefficient of x divided by coefficient of x square. So alpha plus beta, this is equal to minus b upon a. Okay, and the product of its zeros alpha times beta, this is equal to 2, and this is basically equal to constant term divided by coefficient of x square, that is c upon a. So alpha times beta, this is equal to c upon a. So if a is equal to 1, then b is equal to 3 and c is equal to 2. So from these relationships you get the value of a, this is equal to 1, b is equal to 3 and c is equal to 2. So one quadratic polynomial which fits the given conditions is x square plus 3x plus 2. Okay, so these given conditions can be fit by the given by this quadratic polynomial x square plus 3x plus 2. Okay, so one quadratic polynomial which fits the given conditions is basically x square plus 3x plus 2. But you can check that any other quadratic polynomial that fits these conditions will be of the form k times x square plus 3x plus 2, where k is real number. Okay, so let us now look at cubic polynomials. So you know what is cubic polynomials? A polynomial of degree 3 is basically called cubic polynomials. Okay, so now we'll look at cubic polynomials, and here we'll look at the relationship between zeros and coefficients of a cubic polynomial. So do you think a similar relation holds between the zeros of a cubic polynomial and its coefficients, as like linear polynomials, quadratic polynomials? Okay, so let us consider here first the quadratic polynomial p of x. This is equal to 2x cube minus 5x square minus 14x plus 8. So now you can check that p of x, this is equal to 0 for x is equal to 4 minus 2 and 1 by 2. And since p of x, this is a cubic polynomial, so p of x can have at most 3 zeros. Okay, so p of x can have at most 3 zeros. These are the zeros of this cubic polynomial. So 4 minus 2 and 1 by 2 are the zeros of 2x cube minus 5x square minus 14x plus 8. So now you can verify this sum of the zeros, that is basically equal to 4 minus 2 plus 1 by 2, and if we calculate it, then you will get this is equal to 5 by 2. So 5 by 2 can be written as minus of minus 5 by 2. Okay, and this is basically equal to minus of coefficient of x square divided by coefficient of x cube. So here you can observe that the coefficient of x square is minus 5 and the coefficient of x cube is 2. So here sum of the zeros, this is basically equal to minus coefficient of x square divided by coefficient of x cube. Now product of the zeros, this is equal to 4 times minus 2 times 1 by 2, and this is equal to minus 4, and it can be written as minus 8 upon 2. And if you see the cubic polynomial, then you will see minus 8 is basically a constant term. Here 8 is basically constant term of this cubic polynomial, and the coefficient of x cube is 2. So minus 8 by 2, this is basically equal to minus constant term divided by coefficient of x cube. However, there are one more relationship here. Consider sum of the products of the zeros taken 2 at a time. Okay, so when we taken 2 zeros at a time, and if we take sum of the products of these zeros, okay, then we'll get another relationship. So if we product this 4 times minus 2 and minus 2 times 1 by 2 and 1 by 2 times 4, and if we take sum, this is basically equal to minus 8 minus 1 plus 2, and this is equal to plus minus 7. Okay, and this can be written as minus 14 by 2, and this is equal to coefficient of x divided by coefficient of x cube. Okay, so you can see the cubic polynomial, given cubic polynomial here. Minus 14 is basically coefficient of x and 2 is basically coefficient of x cube. Okay, so here we get this relationship when we take sum of the products of the zeros taken at a time 2, that is equal to coefficient of x divided by coefficient of x cube. So in general, it can be proved that if alpha, beta and gamma are the zeros of a cubic polynomial ax cube plus bx square plus cx plus d, then sum of its zeros, that is alpha plus beta plus gamma, this is equal to minus of coefficient of x divided coefficient of x square divided by coefficient of x cube, that is equal to minus b upon a. Okay, and alpha times beta plus beta times gamma plus gamma times alpha, this is equal to basically equal to constant term divided by is equal to C upon, sorry, here alpha times beta plus beta times gamma plus gamma times alpha. This is basically equal to coefficient of x divided by coefficient of x cube, and this is equal to C upon A. And if we take the products of these three zeros, alpha times beta times gamma, and this is equal to actually minus of constant term divided by coefficient of x cube. Okay, so now let us explore some more examples. So here we have to verify that 3 minus 1 minus 1 by 3 are the zeros of the cubic polynomial p of x. This is equal to 3x cube minus 5x square minus 11x minus 3. Okay, and then we have to verify the relationship between the zeros and the coefficients. Okay, so first we have to verify these are the zeros of this cubic polynomial. So comparing the coefficient, comparing the given polynomial with ax cube plus bx square plus cx plus d, then we get a is equal to 3, b is equal to minus 5, and c is equal to minus 11, and d is equal to minus 3. Okay, and further, if we replace the value of x is equal to 3 in given polynomial, then p of 3 is equal to 3 times 3 cube minus 5 times 3 square minus 11 times 3 minus 3. Okay, and if we calculate it, then we will get this is equal to 81 minus 45 minus 33 minus 3. Okay, and this is equal to 0. So at x is equal to 3, the value of the cubic polynomial is equal to 0. Okay, so 3 is a 0 of this cubic polynomial. And similarly, you can check p of minus 1. So p of minus 1, this is basically equal to 3 times minus 1 cube minus 5 times minus 1 square minus 11 times minus 1 minus 3. Okay, and this is equal to minus 3 minus 5 plus 11 minus 3, and this is equal to 0. So at x is equal to minus 1, the value of the given cubic polynomial is equal to 0. So minus 1 is also a 0 of this cubic polynomial. And next, p of minus 1 by 3, this is equal to 3 times minus 1 by 3 cube minus 5 times minus 1 by 3 whole square minus 11 times minus 1 by 3 minus 3. Okay, and if you simplify this, then you'll get this is equal to minus 1 by 9 minus 5 by 9 plus 11 by 3 minus 3. And this is equal to minus 2 by 3 plus 2 by 3, and this is equal to 0. Okay, so at x is equal to minus 1 by 3, the value of the given cubic polynomial is also 0. So minus 1 by 3 is also a 0 of this cubic polynomial. So here verified 3 minus 1 and minus 1 by 3 are the zeros of this cubic polynomial. Okay, so we take here alpha is 3, beta is minus 1, and gamma is minus 1 by 3. And we have to verify relationship between zeros and the coefficients of a cubic polynomial here. Okay, so now if we take sum alpha plus beta plus gamma, this is equal to 3 plus minus 1 plus minus 1 by 3. Okay, and if we simplify this, then we will get this is equal to 2 minus 1 by 3, and this is equal to 5 by 3. Okay, and you can write this is equal to minus of minus 5 by 3, and this is basically equal to minus of coefficient of x square divided by coefficient of x cube, that is minus b upon a. Okay, and then if we take sum of product of the zeros taken two at a time, okay, then alpha times beta plus gamma times beta plus gamma times alpha, this is equal to 3 times minus 1 plus minus 1 times minus 1 by 3 plus minus 1 by 3 times 3, and this is equal to minus 3 plus 1 by 3 minus 1. Okay, and this is equal to minus 11 by 3. Okay, this is equal to minus 11 by 3. And if we compare with the given cubic polynomial, okay, then we will get this is basically equal to coefficient of x divided by coefficient of x cube. Okay, and now if we take product of these three zeros, that is alpha times beta times gamma, this is equal to 3 times minus 1 times minus 1 by 3, and this is equal to 1. And you can write this is equal to minus of minus 3 upon 3, and here this is basically equal to minus of constant term of this cubic polynomial divided by coefficient of x cube, that is equal to minus t upon a. Okay, so here verified. So now we will summarize. So in this chapter you have studied the following points. First point is polynomials of degree 1, 2, 3 are called linear, quadratic and cubic polynomials respectively. Okay, and then second point, a quadratic polynomial in x variables with real coefficient is of the form ax square plus bx plus c, where a, b, c are real numbers and a not equal to 0. Okay, and the zeros of a polynomial p of x are precisely the x coordinates of the points where the graph y is equal to p of x intersects the x-axis. And the fourth point, a quadratic polynomial can have at most 2 zeros and a cubic polynomial can have at most 3 zeros. And fifth point, if alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then alpha plus beta, this is equal to minus b upon a, and alpha times beta, this is equal to c upon a. And if alpha, beta, gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma, this is equal to minus of b upon a, alpha beta plus beta gamma plus gamma alpha, this is equal to c upon a, and alpha beta gamma, this is equal to minus d upon a. Okay, and plotting of graphs of a quadratic or cubic polynomial is not meant to be done by the students, nor is to be evaluated. Okay, so here alpha, beta are Greek letters pronounced alpha and beta respectively. We'll use later one more letter, gamma, pronounced gamma. Okay, and not from the examination point of view here. So I stop here this lecture. Thank you very much to all of you.